Problem E2B2 says, imagine that a particle with positive charge, positive q, is placed on the x-axis at x equals positive a, and a particle with negative charge, minus 2q, is placed on the x-axis at x equals minus 2a. Find the potential at all points along the axis. Okay, so we'll draw our picture. And this is our y-axis. This is x. And we have a positive charge, q, here. And we have a negative charge, negative 2q, here. And the distance here is a, and the distance here is a. Now we're looking for the potential. So the potential, phi, is equal to k q over r. Now when we have two charges, we can use the superposition principle. So that means that if we're going to find at some point along the y-axis, it can be any point, and we'll just pick a p value, and we'll call this y, the distance from the origin to our position p, we'll call that y. And so phi is equal to phi 1 plus phi 2. So phi is equal to, phi 1 is going to be k q, and now what is our r right here? So our r is going to be this distance here. So this is going to be r, and we'll call this p positive. So r at p from the positive charge. And so r at p, if we think about the vector, is equal to, our x value is 0 and our y value is y, and r of, call it plus, is equal to a, and this would be 0. And now let's find our r of minus. R minus is going to equal, and these are vectors, I'll in my vector signs. R minus is going to be equal to a negative a and 0. Okay, so now I'm looking for Rp plus is going to equal Rp minus R plus. And so that's going to equal 0y minus a0. And we get a negative a and y. And if we're looking for Rp minus, we do the same thing and we get, so Rp is 0 minus a negative a. So we'll say this is 0 and this is y minus a negative a and 0. So we get a negative a and positive y. So we get a, so this is actually going to be positive right here, and that makes sense because my vector points from the negative charge. So this is my Rp minus, and so the vector points this way, which is a positive x. So I would expect x to be positive, and it is here. A 0 minus a negative is a positive. Okay, so phi, I'm going to plug in, this is going to be my total phi, so this is my phi 1, and my distance, so to find this magnitude, that's what I need. This magnitude, Rp plus the magnitude, is equal to the square root of negative a squared plus y squared. So that's what goes here, and that's going to be a squared plus y squared. And I'm going to have plus k, and now my charge here is going to be 2q, negative 2q. And this is also going to be the square root of, so if I do Rp minus, I have the same thing. Now this just becomes a negative, but it's squared, so it's the same. A squared plus y squared. Okay, so now when I add them up, phi is equal to, I have a kq here, my denominator is the same for both, so I have a squared plus y squared. And I have kq minus 2kq, so that gives me a negative kq. So now, in order to, so a would be some number, and that would be the distance from the y-axis that my charge is located, and I can plug in q, and now y, I can pick any point along the y-axis. I can pick a positive value or a negative value, and I can plug that number in to find phi at any point along this y-axis. And notice too that my potential is a scalar, so it doesn't have a magnitude, or it only has a magnitude, it doesn't have a direction, so it's just a number.